All right, so we're going to dive into this stack of notes you sent over about clean code.
Okay.
I know you are all about leveling up your coding skills.
Mm-hmm.
And trust me, this stuff is gold.
Right.
It's not just about making the computer happy,
Right.
It's about writing code that other humans, including yourself 6 months from now, can actually understand.
Exactly, like you hit the nail on the head.
Yeah.
Think of it this way. Code is a form of communication.
Okay.
And just like with any language, clarity is key.
Mm-hmm.
You wouldn't write a novel with cryptic sentences and zero punctuation, right?
Definitely not.
Yeah.
I've tried reading some of my old code.
Oh, yeah.
Let's just say it wasn't Pulitzer Prize worthy.
Been there.
So this presentation you sent over,
Yeah.
it seems to define clean code as code that's easy to read, understand, and modify by anyone, not just the person who wrote it.
Exactly. And there's this great quote from Martin Fowler that sums it up perfectly. Any fool can write code that a computer can understand. Good programmers write code that humans can understand.
Oh, that's good.
That's what sets apart the truly skilled coders from the rest.
Okay, that makes sense. But why should we care about this so much?
Right.
I mean, if the code works, isn't that good enough?
Well, imagine trying to read a research paper where the sentences are all jumbled up and there's no clear structure or flow.
Right.
It'd be a nightmare to understand, right?
Yeah.
Code is similar.
Okay.
When it's messy, it overloads our brains, just like that jumbled research paper.
So reading messy code is like a mental workout that nobody signed up for.
Precisely.
Yeah.
Our working memory can only hold so much information at once. Remember the magic number 7 concept? Trying to decipher convoluted code pushes us beyond that limit.
Okay.
And when we hit cognitive overload,
Yeah.
mistakes happen, bugs creep in, and projects get delayed.
Right. So it's not just about aesthetics. It's about efficiency and preventing errors. The presentation also mentions rubber duck programming, which sounds kind of funny.
Yeah.
What's that all about?
It's a debugging technique where you explain your code line by line to a rubber duck or any inanimate object.
Okay.
Sounds silly, but it works.
So I'm picturing myself having a serious conversation with a rubber duck about my code right now.
You'd be surprised how many errors you catch just by talking it out.
Interesting. So clean code helps prevent those late night debugging sessions.
For sure.
What other benefits does it offer?
Well, it's like this. Have you ever inherited a code base that was so poorly written it felt like trying to defuse a bomb?
Ugh, don't even remind me.
Okay.
I once spent weeks untangling spaghetti code just to make a minor change.
Exactly. That's what the presentation refers to as glass-breaking code.
Okay.
It's so fragile that any attempt to modify it can lead to a cascade of errors. Clean code, on the other hand, is more like a well-built Lego structure.
Okay.
You could easily swap out pieces or add new ones without breaking the whole thing.
So it's more maintainable and adaptable. Makes sense.
Right.
The presentation goes on to discuss some core principles of clean code,
Ah.
starting with DRY. I've heard that one before, but can you refresh my memory?
DRY stands for don't repeat yourself.
Right.
And it's all about avoiding redundancy in your code. Think of it like packing for a trip.
Yeah.
You wouldn't bring 2 identical toothbrushes
Right.
unless you absolutely needed to, right?
That would just take up unnecessary space in my suitcase.
Exactly.
So how does that apply to code?
Let's say you need to perform a specific calculation,
Okay.
multiple parts of your program. Instead of copying and pasting the same code block everywhere, you'd create a single function or method to encapsulate that logic.
Okay.
And then call it whenever needed.
Right.
This keeps your code concise and prevents inconsistencies if you ever need to change that calculation.
So it's about writing more efficient and maintainable code. Got it. What about the next principle, KISS?
KISS stands for Keep It Simple, Stupid.
Okay.
It's a reminder to avoid overcomplicating your code.
Right.
Think of it like explaining something to a 5-year-old.
Okay.
You wouldn't use jargon or complex technical terms, right?
I see your point, but sometimes problems are inherently complex.
Right.
How do we balance simplicity with the need to solve those challenging problems?
That's where the art of good design comes in.
Okay.
You need to break down complex problems into smaller, more manageable pieces, and then solve each piece in the simplest way possible.
Right.
This makes your code easier to understand, debug, and modify.
So it's about finding that sweet spot between oversimplification and unnecessary complexity.
Exactly.
What's next on the clean code checklist?
Next up is YAGNI.
Okay.
you ain't gonna need it.
All right.
This principle encourages you to focus on the features and functionality that are actually needed right now,
Yeah.
rather than trying to anticipate every possible future need.
So it's like resisting the urge to buy that fancy kitchen gadget that looks cool, but you'll probably never use.
Exactly.
Yeah.
Adding unnecessary code just adds complexity and makes your code base harder to maintain.
Okay.
It's better to keep things lean and mean, focusing on what's essential for the current task at hand.
Okay. I like this principle. It's all about staying focused and avoiding those what-if rabbit holes.
Right.
What other principles does the presentation highlight?
Well, it goes on to discuss the solid principles,
Okay.
which are a set of 5 design principles that can help you write more robust, maintainable, and flexible code.
5 principles, huh?
Yep.
Okay, let's break it down. What's the first one?
The first one is the single responsibility principle.
Okay.
And it's all about keeping your classes and modules focused on a single, well-defined purpose.
Right.
Think of it like this. Think of it like this. You wouldn't ask your accountant to also fix your plumbing, right?
Right. It's about separation of concerns, keep things compartmentalized.
Exactly. The single responsibility principle applies that same concept to code.
Go.
If a class or module is doing too many things, it becomes harder to understand, test, and maintain.
So it's like having a Swiss Army knife. It can do a lot of things, but it's not the best tool for any specific job.
That's a great analogy. It's better to have a set of specialized tools, each designed for a particular purpose.
Right.
The next solid principle is the open-close principle.
Okay.
This one can be a bit tricky to grasp,
Yeah.
but it essentially means that your code should be open for extension, but closed for modification.
Wait, open and close? How does that work?
Right.
It sounds like a paradox.
It's about designing your code in a way that allows you to add new functionality
Okay.
without changing the existing code that's already working.
Mm-hmm.
Think of it like a house with a solid foundation.
Okay.
You can add new rooms or features,
Yeah.
but you don't want to mess with the foundation itself.
Right.
Because that could cause the whole structure to become unstable.
So it's about creating a flexible and adaptable code base without breaking existing functionality.
Precisely. The open-close principle encourages the use of techniques like interfaces and abstract classes to achieve this flexibility. Next, we have the Liskov substitution principle.
Okay, this one always trips me up. Can
Yeah.
you explain it in a way that even I can understand?
Sure. Imagine you have a program that works with different types of birds.
Okay.
You have a bird class,
Yeah.
and then you have subclasses like duck, eagle, and penguin.
Okay.
The Liskov substitution principle states that you should be able to use any of these subclasses interchangeably with the bird class without breaking the program.
So if my code expects a bird to be able to fly, and then I substitute in a penguin, things are going to go wrong because penguins can't fly.
Exactly. That would violate the Liskov substitution principle.
Oh, okay.
It's about ensuring that your subclasses maintain the expected behavior of their parent classes.
So it's about creating a hierarchy of classes that are truly interchangeable.
Right now, let's move on to the interface segregation principle.
Okay.
This principle is about designing interfaces that are specific to the needs of the clients that use them.
So instead of having one giant interface that does everything,
Yeah.
you have smaller, more focused interfaces.
Exactly. It's like ordering food at a restaurant.
Yeah.
You don't need to know the entire menu, just the dishes that are relevant to your taste.
Makes sense. So each client only interacts with the methods that are relevant to their needs.
Right. And finally, we have the dependency inversion principle,
Okay.
which is about decoupling high-level modules from low-level modules.
Okay, that sounds a bit abstract. Can you give me a real-world example?
Sure. Imagine you're building a car.
Okay.
You wouldn't want the steering wheel to be directly connected to the engine, right?
That would be a very bumpy ride.
Exactly. You would want some sort of interface or abstraction layer in between
Yeah.
to handle the communication between those components.
Right.
That way you can change the engine without having to redesign the steering wheel.
So it's about creating a more modular and flexible system.
Precisely, the dependency inversion principle helps you achieve that by ensuring that your modules depend on abstractions rather than concrete implementations.
Okay. I think I'm starting to get the hang of these solid principles. They seem to revolve around creating code that is well-structured, adaptable, and easy to maintain.
Absolutely. And the presentation also emphasizes the importance of naming conventions.
Yeah.
You know, those seemingly small details like using upper camel case for class names and lower camel case for methods and variables.
Yeah, I've always been a bit lazy with naming conventions. Is it really that big of a deal?
It might seem trivial, but trust me, it makes a huge difference in code readability.
Okay.
Think about it. When you're reading a book, you expect proper grammar and punctuation. It makes the text flow smoothly and helps you understand the meaning.
So well-chosen names are like the grammar and punctuation of code.
Exactly. They make your code easier to read and understand.
Okay.
Plus, if you're working on a team, consistent naming conventions make collaboration much smoother. Imagine if everyone on a construction crew used different terms for tools and materials.
Chaos.
Good point. Consistent naming conventions create a shared language for everyone working on the project.
What else does the presentation say about practical clean code tips?
Well, it goes into detail about code formatting, emphasizing the importance of consistent indentation spacing and use of braces.
Yeah, I've seen some code that was so poorly formatted it looked like a jumbled mess.
Right.
It makes a huge difference when things are laid out clearly.
Absolutely. It's like organizing your workspace. A clean, well-organized space is more conducive to productivity, right?
Definitely, clutter just creates distractions and makes it harder to focus.
Right.
So consistent formatting helps create a more visually appealing and easier to read code base.
Precisely. The presentation also delves into writing effective conditional statements, recommending techniques like avoiding unnecessary comparisons with true and false, using the ternary operator for concise expressions, and utilizing enums instead of direct string comparisons.
So it's about making conditional logic as clear and straightforward as possible.
Exactly. The presentation goes on to offer advice on writing clean methods, suggesting that they should be short-focused and follow the one-screen rule.
The one-screen rule? What's that?
It means that a method should ideally be short enough to fit on a single screen without scrolling.
Oh, okay.
This keeps the logic manageable and easy to grasp.
Okay, so no more giant methods that scroll on forever. What else about methods?
It also recommends limiting the number of nested structures, avoiding deep arrow code, and strategically using return statements or exceptions for early exits.
So it's about keeping the flow of logic as linear and easy to follow as possible.
Right. And when it comes to classes, the presentation stresses the importance of cohesion.
Yeah.
Meaning that all the methods within a class should relate to its core purpose.
So if I have a class called shopping cart, all of its methods should be related to managing items in a shopping cart, not, say, handling user authentication or sending emails.
Exactly. Keep your classes focused and avoid mixing unrelated functionalities.
Right.
The presentation also talks about using wrapper classes over primitives, leveraging resource files for GUI strings, and other techniques for improving class design. Now, one topic that often sparks debate is code comments.
Yeah.
What's your take on them?
I've heard some developers say that well-written code shouldn't need any comments, while others believe that comments are essential for explaining complex logic. What's the presentation's stance?
It advocates for writing self-documenting code that minimizes the need for comments.
Okay.
The idea is that if your code is clear and concise with meaningful names and well-structured logic, it should be easy to understand without relying heavily on comments.
So good code should speak for itself, but aren't there cases where comments are still valuable?
Absolutely.
Yeah.
Sometimes you need to explain the why behind a particular piece of code, especially if it involves a non-obvious algorithm or workaround. But the presentation cautions against using comments to state the obvious or repeat what the code already clearly expresses.
So no comments like this loop iterates through the array.
Right. Those types of comments just clutter up your code and don't add any real value.
Yeah.
It also highlights that comments can become outdated and misleading if the code changes, but the comments don't.
Yeah, I've definitely encountered that before. It's like reading a history book that's full of inaccuracies. So the presentation suggests using version control to track code changes instead of relying solely on comments for historical context.
Exactly. Version control provides a more reliable and comprehensive record of your code's evolution. And speaking of tools and techniques for improving code quality, the presentation also briefly touches on concepts like test-driven development refactoring, unit testing code review, and pair programming.
Wow, that's a lot to unpack. Can you give me a quick overview of each of those?
Sure. Test-driven development, or PDD, is a practice where you write tests for your code before you write the actual code itself.
Okay.
It helps you think through the requirements and design of your code more thoroughly.
So it's like creating a blueprint before you start building a house. You have a clear plan to follow.
Exactly. Refactoring involves restructuring existing code without changing its external behavior. It's like cleaning up your house. You're not adding any new rooms, but you're reorganizing things to make them more efficient and aesthetically pleasing.
Okay, so refactoring is all about improving the internal structure and readability of your code. What about unit testing?
Unit testing involves writing small automated tests to verify that individual units of your code are working as expected. It's like having a quality control inspector for each component of your software.
So it helps catch bugs early on before they become bigger problems. What about code review?
Code review involves having another developer review your code to provide feedback and catch potential errors. It's like having a fresh pair of eyes on your work to spot things you might have missed.
Right. It's always helpful to get a second opinion. And lastly, what is pair programming?
Pair programming is a technique where two developers work together at the same computer on the same task.
So it's like having a coding buddy to bounce ideas off of and catch each other's mistakes.
Exactly. Pair programming can lead to higher quality code and faster problem solving. The presentation recommends exploring these practices as valuable additions to your clean code toolkit.
This has been super insightful. I'm already starting to think differently about how I approach coding.
That's great to hear. And the presentation also emphasizes the importance of continuous learning and improvement.
Yeah.
It recommends some additional resources for those who want to delve deeper into the world of clean code.
Perfect. Let's hear them. What resources does it recommend?
It mentions Robert C. Martin's book, Clean Code, a handbook of agile software craftsmanship.
Okay.
It's considered a classic in the field and covers a wide range of clean code principles and practices.
I've heard great things about that book, definitely adding it to my reading list. What other resources does it mention?
It also recommends a plural site series called Clean Code, Writing Code for Humans. This series provides a more visual and interactive way to learn about clean code concepts.
Excellent. I'll check that out.
Yeah.
Any other recommendations?
Yes, it mentions a paper by Robert C. Martin called Design Principles and Design Patterns,
Okay.
which goes into more depth about some of the design principles we've discussed.
Wow. It seems like Robert C. Martin, also known as Uncle Bob, is the go-to guru for all things clean code.
He's definitely a highly respected figure in the software development community.
I'm feeling inspired to level up my coding game, but before we wrap up, there's one more quote from the presentation that I have to share.
Okay.
It's a bit intense, but it really drives home the importance of clean code ready for it.
Hit me with it.
Always code as if the guy who ends up maintaining your code will be a violent psychopath who knows where you live.
Okay, that's a bit dark, but I get the message. Write code that won't make someone want to hunt you down.
Exactly. It's a humorous way to emphasize the importance of writing code that is easy to understand and maintain. After all, you never know who might end up working with your code in the future.
Or who might remember where you live. Speaking of making your code more approachable for others, the presentation touches on two interesting concepts: the broken window principle and the Boy Scout rule. Familiar with those?
Vaguely refresh my memory.
The broken window principle, which originated in criminology,
Okay.
suggests that visible signs of crime and disorder can encourage further crime and disorder.
So if a building has a broken window that's left unrepaired, it's more likely to attract vandals who will break more windows?
That's the idea in the context of software development. It means that if you allow code to become messy and disorganized, it's more likely to attract further messiness and disorganization.
This was like a downward spiral of code decay.
Precisely. On the other hand, the Boy Scout rule is a much more positive concept.
Okay.
It states that you should always leave the code a little bit cleaner than you found it.
I like that. So like a good Boy Scout, we should always be striving to leave things better than we found them, even if it's just fixing a typo or removing some unnecessary code. Those small improvements can add up over time.
Exactly. It's a great mindset to adopt. Now, are there any other golden nuggets from the presentation that you wanted to highlight?
I think we've covered pretty much everything.
Yeah.
This deep dive has been incredibly eye-opening.
Good.
I'm starting to see how these principles can really make a difference in my day-to-day coding.
Yeah, it's not just about writing code that works. It's about writing code that is elegant, maintainable, and a joy to work with.
Well said. It's like the difference between a hastily scribbled note and a well-crafted letter. Both convey information, but one is clearly more thoughtful and enjoyable to read.
And remember, writing clean code is a journey, not a destination. There's always room for improvement, and the more you practice these principles, the more natural they'll become.
Right. It's about developing good habits and a mindset that values clarity and simplicity.
Exactly. And don't be afraid to experiment and find what works best for you and your team. There's no one-size-fits-all approach to clean code.
That's a great point. It's about finding a style and set of practices that fit your specific context.
Absolutely. And remember, the best way to learn is by doing so. Go forth, apply these principles to your own projects, and see the difference they make.
I'm ready to start cleaning up my code. Thanks for sharing your insights with me today. This deep dive has been incredibly valuable.
You're most welcome. It's been a pleasure discussing these principles with you. And remember, if you ever need a refresher, just think of that violent psychopath lurking in the shadows.
I think I'll stick with the image of a well-organized library where everything is easy to find and understand.
That's a much more pleasant image.
To all our listeners out there, we hope this deep dive into clean code has inspired you to level up your coding skills and write code that is not only functional, but also beautiful and a joy to work with.
Until next time, happy coding.